Hello students, I am Preeti Kapoor from Bullseye. I have a teaching experience of around 14 years. In this session, we will take up limits and continuity. You will learn the definition of limit of a function, existence of limit, working rules for finding limit, limit at infinity, continuity of a function, and in the end, you will have some practice questions and the answer key. Now coming to the definition of a limit of a function, we say that limit x approaches a, fx is equal to L if whenever x approaches a, then fx approaches L. Now this basically means that whenever the value of x comes very close to a, then the value of fx should come very close to L. And then we express it by saying that limit x approaches a, fx is equal to L. Now a very important question here is that does this limit always exist? The answer is no. To understand this concept, you have to now learn what is a right hand limit and what is a left hand limit. Now this kind of a limit is called a right hand limit, where x approaching a plus basically means that x is coming very close to a through values greater than a. That is, x is approaching a from the right side of a on the number line. Similarly, this kind of a limit is called the left hand limit, where by x approaching a minus, we mean that x is coming very close to a through values less than a. That is, x is approaching a from the left side of a on the number line. Now, when the right hand limit is equal to the left hand limit is equal to L, then we say that limit x approaches a, fx is equal to L. But if the right hand limit is not equal to left hand limit, then we say that limit x approaches a, fx does not exist. Now these are the working rules for finding out the right hand limit and the left hand limit. The working rule for finding the right hand limit is that replace x by a plus h, where h is a very small positive number, and then take the limit as h approaching 0. To find the left hand limit, we replace x by a minus h, where h is again a very small positive number, and we take the limit as h approaching 0. Now let's take up this question to understand the concept that you just learned. Now because there is a none of these options here, so it becomes very important for us to check whether the limit exists or not. So we go on finding the right hand limit. So for right hand limit, we take x approaching 0 plus, and you have learned that the working rule for this is we in fact take limit h approaching 0 and replace x by 0 plus h here. So we'll have in the numerator 0 plus h, and in the denominator we will have mod of 0 plus h. Now this will ultimately come down to be h upon h limit h approaching 0, which is equal to 1. Now let's take up the left hand limit. So for left hand limit, we have x approaching 0 minus, and the working rule says that we can in fact calculate it by taking limit h approaching 0 and replace x by 0 minus h. So now in the numerator we have minus h, and in the denominator we have plus h limit h approaching 0, and this is equal to minus 1. So you can see here that the right hand limit and the left hand limit is not equal. Therefore, the limit does not exist. That means the correct answer is none of these. That is the fourth option. Again, in this question, there is a none of these options. So we have to be careful about the fact that limit exists or not. So we find out the right hand limit. For right hand limit, we will replace x by 2.5 plus h and take limit h approaching 0. Now this number is slightly more than 2.5, so its greatest integer function will give the answer as 2. When we take on the left hand limit, we will have limit h approaching 0, 2.5 minus h. Now this number is slightly less than 2.5, so its greatest integer function will again be 2. So the right hand limit is equal to the left hand limit is equal to 2. Therefore, the answer for this limit has to be 2. That is the first option. Now these are some important questions for which limit does not exist. From examination point of view, it is better that if you can remember these limits. Now once we are sure that the limit exists or there is none of these kind of an option in our question, then we can simply apply these working rules for finding the value of the limit. The first rule says that put x equal to a in the given function. If f of a is a definite value, then the value of the limit will be equal to the value of the function at that point. So for example, we have a question here, limit x approaches 1. So we simply put x equal to 1 in this entire function. So what do we get here? We get 6 minus 4 plus 3, which is equal to 5, which is a definite value and hence is the answer for the limit in the question. The second rule says that if fx is a rational function, then factorize the numerator and the denominator, cancel out the common factors and then put x equal to a, and if it gives a definite value, it will become the answer for the required limit. So here in this question, if I factorize the numerator, there are two factors, x minus 2 and x minus 4, and limit x approaches 2. So we cancel out these two common factors here. Ultimately, we are left only with x minus 4. Now, if I substitute 2 here in place of x, I get the answer as minus 2, which is a definite value and hence is the answer for our limit. The third rule says that if the given function contains a surd, then simplify it by using conjugate surds. This procedure we also commonly call as rationalization. After simplification, then we put x equal to a, and again if this is a definite value will become the answer for the limit. So for example, in this question, this is a surd here, so we need to rationalize it by its corresponding conjugate, which is under root of 3 minus x plus 1 divided by 2 minus x under root 3 minus x plus 1. So we've multiplied and divided by this term here. Limit x approaches 2. Now applying a minus b and a plus b rule in the numerator, we get a square minus b square here. In the denominator, we again have the same terms. Now the numerator is nothing but 2 minus x, and in the denominator also we have 2 minus x. So they both cancel out, leaving us only with the denominator part, in which we substitute x equal to 2. Then we get under root of 1 plus 1, which is nothing but 1 upon 2, which is a definite value and hence is the answer for the required limit. This fourth rule says that if the given function contains some series capable of being expanded, then after making proper expansion and simplifying, cancel the common factors in numerator and denominator and then put x equal to a, which if gives a definite value will be the answer for your limit. These are some important expansions that are commonly used in questions on limits. The first one is the commonly known binomial expansion. Then you have e raised to power x expansion, a raised to power x, and the expansion of log 1 plus x. Let's take up a question based on log 1 plus x. So we apply the expansion of log 1 plus x as x minus x square by 2 plus x cube by 3 minus x4 by 4 and so on. Whole divided by x, limit x approaches 0. Now there is a common factor x in the numerator and denominator, which we cancel out. So we take x common in the numerator and cancel out with the x in the denominator, limit x approaching 0. Now we apply this value 0 in the left out portion. We get only 1 as the answer. These are some important limits based on these expansions. Again, from examination point of view, it is important for you to remember these limits, which can easily be proved by either using expansions or by using the L'Hopital's rule, which is done under the topic of indeterminate forms. Now let's take up some questions based on the limits that we were taking up. Now this one will remind you that we are basically making use of this limit, which says that we have limit x approaches 0, 1 plus x raised to power 1 by x is equal to e. That is, whatever is here, the same is there in the reciprocal of the power. So when we take up this question, we realize that to solve this question, we have to multiply and divide the power by 4 so that these two numbers can be made same. Limit x approaches 0. Now, by that limit that we were talking in the previous slide, the answer for this is equal to E. Why? Because when x approaches 0, 4x will also approach 0. So we can rewrite this by saying it is nothing but 1 plus y raised to power 1 upon y, limit y approaching 0, where y is equal to 4x. And this entire thing has power 4 in it. So we will have a power 4 here. That makes the answer as e raised to power 4. This is a very important expansion used in questions based on limits. In this expansion, if we apply limit x approaches a on both sides, so we have limit x approaches a, xn minus a n upon x minus a, then I can simply put x equal to a on the entire right hand side, which will make each of these terms as a raised to power n minus 1. And there are n such terms. So this sum will come down to be n a raised to power n minus 1. So remember, we will be using this limit a lot of times in solving the questions. An important point here is that this n should be a rational number. Now this is a question based on the limit that I was just talking about. So here it is of the type xn minus an upon x minus a, limit x approaches a, where you can see that a is 3 and n is 1 by 2. And the answer for this limit is equal to n a raised to power n minus 1. So we put the values of n and a here. We get 1 by 2, 3 raised to power 1 by 2 minus 1, which is nothing but 1 upon 2 root 3. This is another question based on the same kind of limit. So it says xn minus an upon x minus a, limit x approaches a, and here our a is equal to 2. And we know that the answer for this limit has to be n a raised to power n minus 1. Now this answer is given to be 80. We have to find out the value of n, where n is a natural number. Now to find this value of n, we can simply use the options, and you can easily see that this is the only option which is making it true. See, n equal to 5 here will make it 5, 2 raised to power 4, which is nothing but 80. So the answer is third option. These are the trigonometric expansions that are commonly used. The expansion of sin x, cos x and tan x. These are the limits based on the expansions that we were just talking about. So you can see the limit of sin x as x approaches 0 is equal to 0. The limit of sin x upon x as x approaches 0 is 1. This is a very important one. So let's take up a question based on this. Now we have sin 5x upon sin 8x. So if you go back to that limit that I was talking about, here this number and the number in the denominator have to be same. So to be able to use it here, I have to multiply and divide this question by 5x upon 8x. So I can do that without changing the question. Now you can see that this sin 5x and this 5x is making a pair as this to give the answer of the limit as equal to 1. Why? Because when x approaches 0, 5x also approaches 0. So this is nothing but a question of the type sin y upon y, limit y approaches 0, that we just discussed is nothing but 1. Similarly, this sin 8x and this 8x will make a pair to give the limit as 1 again. So sin 8x upon 8x, limit x approaches 0 is equal to 1. Now this remaining part, x will cancel out and this will just give me 5 upon 8. So we get 1 into 5 by 8 into 1, that is 5 by 8 as the answer. This question is based on the limit that we just took up in the previous slides, this one, which says that e raised to power x minus 1 upon x as limit x approaches 0 will always be equal to 1. So we can observe here that if I want to use that limit, it should be of the type e raised to power x minus 1 upon x, limit x approaches 0 is equal to 1. So to make it of this type, I have to basically multiply and divide this question by sin x. In that case, this will make one pair which will be of this type. Why? Because if I put sin x as y, it will be e raised to power y minus 1 upon y, limit y approaches 0. Why? Because when x approaches 0, sin x also approaches 0. So this part will make the limit as 1. The remaining part, which is sin x upon x, that we have already discussed, is equal to 1 as x approaches 0. So both the parts are giving me the limit as 1, which gives me the answer as 1. Now this is limits at infinity. Basically we mean that finding the limit of the function fx as x approaches infinity, that is x is coming very close to infinity. Now what does this logically mean? It basically means that x is becoming a very large number. Then what is happening to the value of fx? That is called as limit at infinity. Now there is a simple working rule for finding the limit at infinity. The rule goes like this: replace x by 1 upon y in the given function. Take the limit as y approaching 0, of course, because if x is approaching infinity, 1 upon y will be approaching infinity. That means y will be approaching 0. In case of a rational function, divide the numerator and the denominator by the highest power of x present in your question. Then replace x by 1 upon y and apply the limit as y approaches 0. So this is one question based on the concept of limit x approaching infinity. So let's just apply the working rule. Working rule says that replace x by 1 upon y. So which will give me y square in the numerator and limit y approaching 0. Now this is an extremely simple limit which we know that will give me the answer as 0 when I put y as 0 here. This is a rational polynomial question, so we will have to first of all divide the numerator and denominator by the highest power of x present in our question, which is x square here. So I divide the numerator by x square and the denominator also by x square, which will give me this in the numerator, and in the denominator I'll have 2 minus 5 by x plus 1 upon x square. Limit x approaches infinity. Now we apply the working rule which says that replace x by 1 upon y, or we can say replace 1 upon x by y. So this is what we get. Now it's a rational polynomial where we can simply put the value of y equal to 0 here, giving us the answer as 5 upon 2, which is a definite value and hence is the answer for the required limit. Now in this question again we have limit x approaches infinity, so we again apply the working rule. We will replace x by 1 upon y, or we can say 1 upon x by y. This is what we get. Now in the power, if I multiply and divide by a, why am I doing it? You will just soon understand this. Then if I put this ay as z, I can make this inner part as 1 plus z raised to power 1 by z, and this entire thing is having power a then, where I can say that as y approaches 0, this ay which I have called as z here will also approach 0. So I can say that limit z approaches 0. Now I hope this reminds you of an important limit that we were talking about, which had 1 plus x raised to power 1 by x, limit x approaches 0 is equal to e. So this portion becomes e and it has a power a, so this is what the value of the limit comes out to be. Now please remember, this is not just a question, but it's a very important formula to solve a lot of questions. Let's take up this question, which you will see will be based on the limit that you just talked about. So we will be using this limit 1 plus a by x raised to power x is equal to e raised to power a. So to begin with this question, we will first of all split this 3 as minus 1 plus 4. The denominator has x minus 1 and the entire power is x plus 3. Limit x approaches infinity. Now I can split this question as 1 plus 4 upon x minus 1 raised to power x plus 3. Now in the next step we will split this power also, and we'll write this power as x minus 1 separate and 4 separate. So we will have limit x approaches infinity 1 plus 4 by x minus 1 raised to power x minus 1, and the other one will be 1 plus 4 by x minus 1 raised to the remaining part, which is 4. So we have split the two parts here. Now this one, if I put x minus 1 as z, this is what is happening here. Now since x is approaching infinity, so x minus 1 will also approach infinity. Now we use the limit that we just discussed in the previous slide, that is 1 plus a by x raised to power x as x approaches infinity is e raised to power a. So here the a that we have is 4. So the answer for this part is e raised to power 4. Now coming to the next part, which is 1 plus 4 upon x minus 1 raised to power 4. As x approaches infinity, this part will become 0. So I will have 1 raised to power 4, that is 1. So e raised to power 4 multiplied by 1 gives me the final answer as e raised to power 4. Now the next concept is continuity. A function fx is continuous at a point x equal to a if the right hand limit is equal to the left hand limit and is equal to the value of the function at that point. That means the limit is existing. Why? Because the right hand limit is equal to the left hand limit. And further we are saying that the value of this limit has to match with the value of the function at that point. Then we say that the function is continuous at this point. Otherwise, fx will be called a discontinuous function at the point a. Now fx is discontinuous at x equal to a in each of the following cases. The first one is the value of the function at the point a is not defined. The second one is the limit x approaches a fx does not exist. The third one is the limit exists but is not equal to the value of the function at that point. And this kind of a discontinuity is called as removable discontinuity. Why? Because it can be easily removed if we redefine this value of the function at the point a and make it equal to the value of the limit. A function fx is said to be continuous. Now remember, we are not saying continuous at x equal to a. We are saying it is continuous in general if it is continuous at each point of its domain. That is, if it is continuous at every point of the domain, then we say that it is a continuous function. Now this is a list of some important continuous functions: constant function, identity function, polynomial functions, rational functions, composite of two continuous functions, which is also a continuous function, exponential function, log functions, sine, cos and tan functions. These are all continuous functions. Now let's take up this question on continuity. We have to check the condition for which fx will be continuous at the point x equal to 4. So the definition of continuity says that the right hand limit has to be equal to the left hand limit, has to be equal to the value of the function at the point, and the point is 4 here. Now for the right hand limit, we take limit x approaches 4 plus, that is x greater than 4. Now for x greater than 4, the function is defined as this, which is x minus 4 divided by mod of x minus 4 plus b. Now since x is greater than 4, so I can skip this mod because x minus 4 will be a positive number, giving me just x minus 4 upon x minus 4 here, which is 1 plus b. So this is the value of the right hand limit. Let's take on the left hand limit now. So for left hand limit, we will have to take x approaching 4 minus, that is the values x less than 4. For this one, the function is defined as x minus 4 upon mod of x minus 4 plus a. So x minus 4 upon mod of x minus 4 plus a. Now since x is less than 4, so this mod, the number inside this mod will be a negative number. So if I skip the mod, I will have to write it as 4 minus x, which will be minus 1 plus a. So this is the value of the left hand limit. Now the last one is value of the function at that point. So the value of the function at the point 4 is given to us as a plus b. So this one is a plus b. Now for the function to be continuous, the left hand limit is equal to the right hand limit is equal to the value of the function. So we equate the three values. The first one is 1 plus b, which is the right hand limit, should be equal to the value of the function, which is a plus b, and should be equal to the left hand limit, which is minus 1 plus a. So if I compare these two, you can easily observe that a has to be equal to 1. And if I compare these two, you can easily see that the value of b has to be minus 1. So the correct option is the fourth option, which says a is 1 and b is minus 1. Now in this question, if you remember that we had talked about this limit under the category of limits not existing at x equal to 0. Now since the limit of this function is non-existing, why? Because the right hand limit will not be equal to the left hand limit. Therefore, if the limit does not exist, the function has to be discontinuous at x equal to 0. So the correct option is the first option. Here in this question, we have the critical point is x equal to 2. Why? Because whenever we have a function of continuity or discontinuity, remember that the only important points majority of the times are the ones where the function is taking a break or it is changing its nature. So we can easily observe that when x is not equal to 2, it is always this rational polynomial which will remain continuous. So the only confusion point can be the point 2. So we have to check whether the function is continuous at x equal to 2 or not. Now, the right hand limit and the left hand limits can together be found here. Why? Because we have a formula for this. If you remember, we had xn minus an upon x minus a, limit x approaches a is equal to n a raised to power n minus 1. So if you compare these two, you can easily observe that a is 2 and n is 4, which will give me the value of the limit as 4 2 raised to power 3, which is 32. So the left hand limit and the right hand limit both are equal to 32, but the value of the function at the point x equal to 2 is 16. So it is a discontinuous function, and just for your knowledge, the type of discontinuity is the removable discontinuity. So the correct option is x equal to 2. Now these are some practice questions. And this is the answer key. I hope this session will help you to understand and solve the questions based on limits and continuity. Thank you.